Until recently, scientists claimed that the oil palm is wind pollinated. Oil palm pollination has always been good in Africa, but oil palm estates in Southeast Asia were experiencing problems. Millions of pounds had to be spent manually pollinating the female flowers. This was a complex and expensive process, and at the end of the day, not wholly satisfactory. In Sabah, East Malaysia, the pollination problems were even greater than in West Malaysia. Why? Scientists blamed lack of wind, low male-to-female ratio of the flowers, and that heavy rainfall in Malaysia, particularly in Sabah, was probably washing the pollen out of the atmosphere. Pollination problems are not usually experienced in Africa, and the seasonal rainfall is higher than in Malaysia. This contradiction led chairman of Unilever's plantation group, Leslie Davidson, then manager of the troubled Sabah estate, to contest the scientists' theories. The planter's instinct, combined with his worldwide experience in tropical agriculture, suggested to him that the oil palm might be insect and not wind pollinated. This belief prompted Unilever, in conjunction with the Commonwealth Institute for Biological Control, to launch an investigation into his theory. Since the oil palm is a comparative newcomer to Southeast Asia, it was necessary to first study the oil palm pollination process in Africa. Tests by entomologists were soon able to establish that, as Leslie Davidson had suspected, in Africa the oil palm is insect pollinated. There were more than 20 species of insects on the male and female inflorescences of the oil palm, and of these, more than a dozen were common to both. More detailed experiments showed that at least 7 or 8 of the species played an important role in pollination. The next logical step was to go to Malaysia to examine the trees there. On an oil palm estate in West Malaysia, entomologists found a local thrips playing a minor, less efficient role in pollination. But the thrips was not present on the estates in Sabah, East Malaysia. This was also true on oil palm estates in surrounding countries. Overall, the African insects looked more promising for introduction into Malaysia and other countries having similar pollination problems. One insect in particular was found to be making an outstanding contribution to oil palm pollination. It was the weevil Yeilds camerunicus. The adults of all the species of Yeilds feed and breed on male inflorescences of oil palm after the flowers have opened and released pollen. They feed only on the inner parts of dead male flowers. As the weevils busy themselves on male flowers, they pick up the pollen grains on the undersides of their bodies. The grains stick mainly to the thorax, abdomen, and under the wings. It was discovered that a single male camerunicus weevil could carry up to a staggering 600 grains of pollen. In repeated experiments, camerunicus clearly displayed the greatest searching and carrying ability. Even the industrious girls in Malaysia could not compete favorably with the weevil. Neither could the wind. Yeilds camerunicus is the pollinator that reaches parts other pollinators cannot reach. By now, it had been firmly established that the camerunicus weevil visited the female flowers only during their period of receptivity. The question arose, why? There is no food available to them on the female flowers, so why go? Studies revealed that the female flowers exude an odor during their period of receptivity, accompanied by a rise in temperature. The odor mimics that of the male flower, so the weevils go to the female flowers thinking they contain food. When they are there, they neither damage nor injure the flowers during their visit. They simply oblige the female flower by delivering the necessary pollen grains. Closer studies showed that the weevils are repelled at close quarters by a chemical deterrent. By this time, of course, they have deposited pollen grains. Fertilization, therefore, is achieved by deception. Scientists now had a clear understanding of how the oil palm was pollinated. The next phase was to study the weevils. Adults of the species Yeilds camerunicus mate at any time of the day, usually 2 to 3 days after emergence, some even sooner. The eggs, measuring less than half a millimeter, are deposited inside the dead male flowers. The tissue surrounding them dries, hardens and shrivels, thus providing some protection for the fetus inside. There are 3 larval stages, or instars. The larvae first feed on the dying tissue surrounding the egg-laying site. After they molt, they move to the base of the flowers where feeding on the soft tissue is resumed. Often the egg and first 2 larval stages of Camerunicus are complete in 2 to 3 days. The mandibles of these young larvae are weak and incapable of cutting through to the next flower. This necessitates completion of these instars within the same flower. Before the flower is fully consumed, the larva molts again, and at the 3rd stage continues feeding from the base of the anther tube. The larva now has stronger mandibles and is able to cut a hole near the base of the adjacent flower and resumes feeding from the base upwards. At the 3rd stage, it can also feed on the hardened flowers. In this way, the 3rd stage of the larva may consume 5 to 6 flowers. It becomes inactive for about 1 day prior to pupation. The number of weevils found on male spikelets is related to the stage of flowering. They are few on the 1st day, when only a few flowers have opened, but increase on the 2nd day and are found in maximum numbers on the 3rd, when all the flowers have opened. Camerunicus was always by far the most abundant species, even during the rainy season. The lifestyle of the weevil Camerunicus was now understood. It had been established that they were able to feed and breed successfully on the oil palm. It was then meticulously proven by testing the weevil's response to other plants that the weevil Camerunicus was completely dependent on and specific to the oil palm and posed no danger to other crops. It was also concluded that the oil palm needs the weevil to ensure its very survival. Southeast Asia is now taking advantage of an efficient pollinating agent produced in Africa by nature after millions of years of trial and error. The initial effects of improved pollination were dramatic. After the first full year, yields of fruit increased by 20 to 50%. The Malaysian Minister of Primary Industries, Datuk Paul Yong, estimated that as a direct result of the introduction of the weevils, in 1982, Malaysian plantations yielded an additional 400,000 tons of palm oil and 300,000 tons of palm kernels, with a total value of over 370 million Malaysian dollars. The spin-off benefits have been particularly marked for smallholders. Yields from small holdings in Sabah have increased by nearly 40% since the introduction of the weevils, and at no cost to the farmers. The planter's instinct, supported by Unilever, has paid off for everyone. The introduction of the weevils and the ensuing benefits to the economies of many Southeast Asian countries is the direct result of the initiative of Unilever's plantations management and its facility to transfer know-how effectively within a multinational business.